Dr. Johnson. I'm one of the AP Stats teachers at Capella High School. Welcome you to this presentation on the Angel of Death, the case of the United States versus Kristen Gilbert. Kristen Gilbert started working at the VA hospital in Northampton, Massachusetts as a nurse in 1989. A proficiency report described her as highly skillful, calm, and compassionate. Outside of work, she organized charity drives and collections for the needy. However, Gilbert did have a tendency to be nearby when patients died. Coworkers sometimes referred to her as the Angel of Death. On several occasions, she was the first one to notice that a patient was going into cardiac arrest and to sound a code blue to bring the emergency resuscitation team. She always stayed calm and was competent and efficient in administering to the patient. Sometimes she would give the patient an injection of the heart stimulant drug epinephrine to attempt to restart the heart before the emergency team arrived, occasionally saving the patient's life this way. Gilbert's coworkers started to raise concern about an increase in medical emergencies, the code blues, and deaths in her ward. There had been several unexplained shortages of epinephrine. But all this was suspicion. They didn't have any direct evidence. No one saw her do anything wrong. And I want to remember, in a criminal trial, the defendant is entitled to a presumption of innocence. It's the government's duty to prove each and every element of the crime beyond a reasonable doubt. We don't convict people on suspicions. So the hospital launched an initial investigation but found nothing unusual. In particular, the number of cardiac deaths at the unit closely aligned with that of other VA hospitals. I want to talk a second about the difference between direct evidence and indirect evidence. They had no direct evidence that she did anything wrong. There was only indirect evidence, but sometimes indirect evidence can be pretty compelling. Indirect evidence requires an inference, and that's what we do in statistics. We often make inferences. I want to give you an example. Suppose that you're training your dog not to get up on the sofa. So some morning you come down and you see, some dog fur on the sofa and a warm spot on the sofa. Well, that's pretty compelling evidence that the dog was on the sofa, but it's not direct evidence, it's indirect evidence. One time, Kristen pulled a bottle of epinephrine out of her pocket to offer it to Nurse Bonnie Bledsoe. This shows Kristen did have access to epinephrine. But who else had access to epinephrine? Nurse Kathy Ricks counted 3 bottles of epinephrine at the beginning of her shift. At the end of the shift, there were none. One of Kristen's patients experienced cardiac arrest during that shift. Possibly only coincidence, but we can't say that we know that the patient's heart attack was in fact caused by epinephrine either. An anonymous nurse said she heard one of Gilbert's patients yelling, "Stop, stop, you're killing me." At that time, Gilbert was in the room. The patient later died. The nurse is anonymous, for heaven's sakes. We can't cross-examine a nurse based on what is essentially hearsay. I mean, if you're trying to frame someone, isn't this the kind of stuff that you'd make up? Did she have a motive? Well, prosecutors are not required to prove motive, but sometimes motive does help explain actions. Perhaps she liked the excitement of the code blue alarm process and the resuscitation process, plus the recognition of having struggled valiantly to save the patient. As a nurse, Ms. Gilbert did have access to epinephrine, but since no one had seen her administer any fatal injections, the case against her was purely circumstantial. Now let's consider the victims. Most of the patients were middle-aged men, not regarded as potential heart attacks. Is it possible that their attacks occurred naturally? In this case, the crucial question for the grand jury was whether there was significantly more deaths in the unit when Kristen Gilbert was on duty than at other times. The key word here is significantly. A few extra deaths on her watch is probably just coincidence. How many deaths would it take to reach a level of significance sufficient to charge Gilbert? To answer this question, this statistical question, a statistician named Stephen Gelbach was asked to provide evidence to the grand jury. One of the first things Gelbach did was to plot the annual number of deaths at the hospital from 1988 through 1997, broken down by shift, the night shift, the evening shift, and the day shift. Each vertical bar shows the total number of deaths in the year during that particular shift. In March 1990, Gilbert started working at the VA hospital. During 1990, she worked at the night shift. From 1991 to 95, she worked the evening shift. And February 1996, that's when she stopped working at the VA. So here are the shifts that she was working on, highlighted in red. For each of the years she worked at the VA, the shifts that she worked had an increased number of deaths. Now, to the layperson, this is suggestive that Gilbert was responsible for the deaths. The problem is that it may be just coincidence. Remember, the government's duty is to show each and every element of the crime beyond a reasonable doubt. And a reasonable person can believe that this could be caused by coincidence. Here's the data on 1,641 8-hour shifts covering the 18-month period ending in February 1996, the month when the 3 nurses told their supervisor of their concerns, shortly after which Gilbert took a medical leave. Altogether, there were 74 deaths spread out over 1,641 shifts. So, what are the observational units, the explanatory variable, and the response variable? Well, the observational units are the shifts, not the patients. The explanatory variable was whether Gilbert was on the shift. That's a categorical and binary variable. The response variable is whether there was a death on the shift. Again, a categorical and binary variable. If the deaths are assumed to have occurred randomly, these figures suggest that the probability of death on any shift was about 74 out of 1,641, or 0.045. Focusing now on the shifts when Gilbert was on duty, the probability of death on any one shift was about 40 out of 257, or 0.156. The actual percentage difference in death rates between these groups is about 503%. Yes, that's right. The death rate on Gilbert's shift was 503% higher than the death rate on the non-Gilbert shift. Could the increased number of deaths at the hospital during the shift when Gilbert was on duty have arisen due to chance variation? Well, there's a couple explanations. One explanation is that the true proportion of people who die on Gilbert's shift is 0.045, and we got a sample of 0.156 by random chance alone. And then there's this other alternative. The true proportion of people who die on Gilbert's shifts is greater than 0.045. Let's do this as a simulation. Suppose we generate 1,000 random samples, each of size n equal 257, from a population with a proportion of 0.045 successes. Success in this case occurs when there's a death on the shift. And I'm going to let X be the number of deaths in 257 shifts. The graph on the right shows the results of our simulation. There were there were 40 deaths in the 250 shifts that Gilbert was on duty. But look at this, the simulation showed no outcomes of 40 or more. Let me superimpose a normal distribution over the binomial distribution. Notice that the binomial distribution in this case is approximately equal to the normal distribution. Suppose the probability of death on Gilbert's shift is 0.045. Remember, if the deaths are assumed to have occurred randomly, the probability of death on any one shift was 74 out of 1,641, or 0.045. Now let X equal the number of deaths in her 257 shifts. Is this a binomial random variable? Well, binary. Either a death occurred or it didn't. Are the number of trials fixed? Yeah, there are 257. She had 257 shifts. Are the trials independent? We assume that they are independent. Is the probability of death on the shift constant? Yeah, 0.045. So what is the mean and standard deviation of X? Well, I'm going to use my formulas for mean of a binomial random variable and standard deviation of a binomial random variable. If Gilbert was not killing any of the patients, we would expect that there would be around 257 times 0.45 or 11.6 deaths on her shifts. So in around 11 or 12 deaths. In fact, there were more, 40 to be precise. And here's my calculation of standard deviation. I'm going to skip this slide right here. So, if the probability of death per shift is 0.045, what is the probability of 40 or more deaths in 257 shifts? We can solve this using our calculator's binomial CD function. Okay. In fact, the probability that X is between 40 and 257 is almost zero. It's 1.2 times 10 to the minus 11, so it's almost zero. Statistically, Gilbert calculated that the probability of having 40 or more deaths occur on Gilbert's shift was less than 1 in a million. In other words, it is unlikely in the extreme that Gilbert's shifts were merely just unlucky for patients. On my previous slide, I used a simulation to calculate the p-value. I also used a binomial distribution to calculate the p-value. But we can also solve this problem using a technique called the normal approximation of the binomial. In other words, remember this, on the other slide I calculated the mean and standard deviation of X. I can also show that NP is greater than 10 and N times 1 minus P is greater than 10. So in this case, our binomial distribution is approximately normal. You might also remember that on a previous slide, I superimposed the normal distribution over the binomial distribution, and we saw that the binomial distribution was approximately equal to the normal distribution. So we can solve this using the techniques we learned in Chapter 2 and our normal CD function on the calculator. So we calculate the Z value for the number of deaths, and we calculate our probability. And the probability, again, is almost zero. Generally, using the binomial calculation to find the p-value is more exact than the approximation based on a normal model, but as you can see in this case, the results are quite close. The grand jury was presented with the statistical analysis of Gilbert and found probable cause that Kristen had committed multiple murders. The grand jury decided there was sufficient evidence to charge or indict Gilbert. The defense hired another statistician named George Cobb. I like it. George Cobb raised another point. Correlation does not prove causation. Whenever a calculation of probabilities is made based on observational data, the most that can generally be concluded is that there is a correlation between two or more factors. It does not establish causation. There could be a hidden third variable, a third person, that lies behind the correlation. To prove causation, you need to show that all other possible causal factors have been accounted for by design or statistical control. The jury found sufficient evidence to convict her of 3 counts of first-degree murder, 1 count of second-degree murder, and 2 counts of attempted murder. Because the VA hospital is a federal facility, the trial was held in a federal court rather than a state court and subject to federal laws. This was significant for Gilbert because the federal law allows the death penalty, although Massachusetts law does not. Although the prosecution asked for the death penalty, the jury split 8-4 on that issue, and accordingly, Gilbert was sentenced to life imprisonment with no possibility of parole. The statistician Gilbert carried out an analysis that showed that the increased number of deaths at the hospital during the shifts when Gilbert was on duty could not have arisen by chance alone. What Cobb argued was that the establishment of statistical relationship does not explain the cause of that relationship. The judge in this case accepted Cobb's argument, since the purpose of the trial was to determine whether or not Gilbert caused the death. His reason for excluding the statistical evidence was that, as experience in previous court cases has shown, jurors are not well versed in statistical reasoning. Typically, if the jurors learn that the probability is less than 1 in a million that these deaths could be occurred by chance, they are likely to jump to the conclusion that Gilbert caused the deaths. But the statistical evidence does not make Gilbert the only possible cause. This story does have a happy ending. Cobb agreed with Gilbert's basic statistical analysis. They went on to write a joint paper about this case, and presumably Cobb and Gilbert received handsome consulting fees. I hope you enjoyed this. Thank you for listening.